So, welcome everybody to chapter 3, where we talk about national income, where it comes from and where it goes. So, the chapter is pretty long, therefore I will divide this lecture into at least 2 videos. And let's start with the first chapter, which deals with the determinants of total production. The following graph highlights once more the circular flow within one economy. You can see the 3 actors: households, government, and firms. The households receive income from the market for factors of production. It is very important that we distinguish capital and labor. So the households get wages, but also profits and dividends from the factor markets. Afterwards, the households have to pay taxes to the government, and they can buy some goods at the markets for goods and services. This is where the firms get their revenues from, and the firms are paying wages and profits to the factors of production. The government is receiving taxes from the households. The government is also spending some money to buy police cars and weapons. Government purchases at the goods market, and the government might have a government budget deficit or a government budget surplus, and therefore is also acting at the financial markets. What I would like to pronounce once more and highlight is factor payments. The wage rate is a compensation for the factor labor, and the rent R, this is a compensation for the factor capital K. So don't set income equal to wages. This is not right. Income cannot be used as a synonym for wages, because then we would miss the second component, the rents. Furthermore, public savings, like savings of the government, can be positive or negative. In case that tax income is larger than government spending, then public savings is positive. The government is running a government budget surplus. And in case that government spending is larger than tax revenues, then public savings is negative and the government runs a government budget deficit. Let's come up with some assumptions with respect to the factors of production. In this part of the lecture, we assume that the factors of production within one economy are fixed. We denote that with a bar above one variable, which is called like overbar. So here, equation 1 says capital is fixed and labor is also fixed. And here it is very important to look at this word of the assumption, that it is related to the economy. It's not related to the firm. One firm can expand by hiring more labor and by also buying more capital goods. So one firm can expand, but the resources of one economy are given. Then it is also very important to understand that we are looking at a classical model. In a classical model, unemployment is not a problem. There is no unemployment in this model class. Unemployment will be explained in chapter 7. The factors of production are fully utilized, so like the whole labor force is working and the economy is using also all the machines which are available. Let's have a look at the production function. The output is a function of capital and labor. F is the symbol for the function. This production function has special characteristics, and one characteristic is called that this production function has constant returns to scale. And this implies when inputs double, also output doubles. Or, in more general terms, output corresponds in a proportional way to variations in inputs. This is mentioned in the textbook in the following way. In case that you are like increasing k by the factor z and you are increasing L by the factor z, then the output will increase by the factor z. I would like to give one numerical example to really show that this is indeed the case. So we have to specify a production function, and the production function I would like to work with is the following one. Output is equal to A, which is a technology parameter, times k to the power of 0.5 times L to the power of 0.5. As mentioned already, the variable A symbolizes the technology, and we assume right now A is equal to 1. Furthermore, we assume that Denmark is equipped with K is equal to 4 capital units and L is equal to 4 labor units. How does it look like in the real world? Like in the real world, it looks like that. There are 4 bonnemen, so 4 farmers. L is equal to 4, and they all have like a fork, so the number of forks in the Danish economy is equal to 4. Let's check how many units of output can be produced in case that k is equal to 4 and L is equal to 4. Let's plug in these numbers in the production function. This is a production function. We have to consider that A is equal to 1, so this will disappear in the next step. And k to the power of 0.5 is nothing else than the square root of k. Also, L to the power of 0.5 is the square root of L. So we can write our output function in the following way. Output is equal to square root of k times square root of L. When we plug in the numbers, we have to take the square root of 4, the square root of 4. So it's 2 times 2, so the output is equal to 4. So Denmark is able to produce 4 output units. Why this numerical example? Why is this numerical example important? It is important because I would like to show that this production function, which I introduced, has the following characteristic. Like this production function I introduced has constant return to scale, and this implies when inputs double, output doubles, or like output corresponds in a proportional way to variations in input. Let's compare Denmark to another country. Let's compare Denmark to Sweden. We assume that Sweden is 125% larger than Denmark, so that the parameter z takes a value of 2.25. This implies that Sweden has more labor units, z times the labor units of Denmark, so 2.25 times 4. Sweden is able to produce with 9 labor units. What about capital? Also here, Sweden has 2.25 times the capital units of Denmark, so Sweden is producing with 9 capital units. How does it look like in Sweden? Of course, we have L is equal to 9, we have 9 farmers and 9 forks. Then the big question is, what can be produced in Sweden? How large is the output in Sweden? In Sweden, we can produce square root of 9 times square root of 9, 3 times 3, which is equal to 9 units of output. And hence, we have proven here that when you increase the production factors proportionally, then also the output corresponds proportionally. So here we have proven that when you are increasing capital and labor by 125%, then also the output increases by 125%. So the production function we are looking at has like constant returns to scale. After we have clarified these characteristics of the profit function, let's have a look at the other components of the model and some more assumptions. The model we are looking at combines some classical ideas which stem from the 18th century and some neoclassical components which stem from the 19th century. The classical idea is that prices balance demand and supply. And the neoclassical theory talks about the distribution. Like the demand for each factor of production depends on the marginal productivity of that factor. This is what we are going to use later on when it comes to our model. So the classical idea, what does that imply? It implies that we are working in a diagram. Factor supply is a vertical line because we assumed that the amount of capital and labor to one economy, because we assumed that the amount of capital or labor within one economy is constant. So therefore, the factor supply is a vertical line. Factor demand depends in a negative way on the factor price. In case that, for example, the wage rate is very high, the quantity demanded will be low, and in case that the wage rate is low, the quantity demanded will be high. The factor price is variable, and the factor price is in the end equating supply and demand. This is the classical idea. Furthermore, the assumptions with respect to the firms are as follows. Like we are talking about a competitive firm, and a competitive firm is relatively small. It has no market power to influence prices. So from the perspective of the firm, the prices are given. The prices are exogenous to the firm. What kind of prices are we talking about? We are talking about the price of output as well as the price of the inputs. So we are talking about the goods price P, which is given. We are talking about the wage rate W, which is given, and the rent is also given to the firm. The firm does not influence these kind of prices. But what is under control of the competitive firm? Like what kind of decisions have to be made? The manager of this firm has to choose the optimal amount of labor and also has to choose the optimal amount of capital. And in order to choose this optimal amount, we need a function which has to be optimized. And therefore, we have to think about the objective of a firm. Here, we assume that the objective of the firm is to maximize profits. So we need a profit function. And profit is defined as revenues minus cost. Revenues, this is given by the price of the good times the quantity of output, and the cost is given by the cost for the factors of production. So the profit is given by revenues, goods price times quantity produced, minus the cost for labor, minus the cost for the production factor capital. Or in case that we want to substitute the production function instead of y, then the revenues are given by the following term, price times the production function, and we are using capital and labor, which we are hiring here. We are using this amount of capital and labor to create output. On slide number 17, we assume that the manager of a firm has to make some decisions with respect to the optimal amount of labor and the optimal amount of capital used in this company. In the following, we will focus on the decision optimal amount of labor. Please have a look at the textbook in case that you are interested in the discussion with respect to the optimal amount of capital. But the different steps to choose the optimal amount of capital are like 100% identical. So let's have a look at the demand for factors, and we are assuming that the demand for the factor labor depends on the marginal productivity of labor. MPL is an abbreviation for the marginal productivity of labor, and it is defined as the extra amount of output from one extra unit of labor holding the amount of capital constant. In the textbook, the formula for the marginal productivity of labor is given in the following way. So the output, which stems from the amount of capital, and this amount of labor, like +1, and then we are subtracting the output we are producing with this amount of capital and that amount of labor. So we want to find out what happens if we are increasing labor input by 1 unit, what happens to output, by how much does output increase. Also here, I think it's very important to have a numerical example to highlight what does equation 16 imply. So let's have a look. We are working with this well-known production function, y is equal to the square root of k times the square root of L. Initially, our company is working with 100 units of capital and 100 units of labor. And then, of course, it is the case that this company can produce 100 units of output. Then the manager of this firm makes one adjustment. The manager increases labor input by 1 unit so that labor input increases from 100 to 101. The big question is, by how much will output increase? So the square root of 101 is equal to 10.05, so that the output is equal to 105, and therefore the marginal productivity of labor is equal to the difference of these two outputs. The marginal productivity of labor is equal to 0.5 good units. The textbook uses this definition of the marginal productivity of labor. Of course, when you already had a class in microeconomics, you also know that the marginal productivity of labor is like the first derivative of the production function with respect to labor. So marginal productivity of labor is equal to first derivative of the production function with respect to labor. The production function is given by this relationship here. And now when we differentiate with respect to L, the well-known formula for creating the first derivative is we should take the exponent and write the exponent in front of the expression, and afterwards we should reduce the exponent by 1 unit. So the formula is we take the exponent, write the exponent in front of the expression, and then we reduce the exponent by 1 unit. So we get for the marginal productivity of labor 0.5 times k to the power of 0.5, and then L to the power of minus 0.5. L to the power of minus 0.5 is nothing else than 1 over L to the power of 0.5, and we can write it differently. We can write this expression in the following way: 0.5 times k to the power of 0.5, and then in the denominator of this fraction, L to the power of 0.5. When we plug in the numbers from our previous numerical example, where k was equal to 100 and L was also equal to 100, then we learn also that marginal productivity of labor is equal to 0.5 times 100 to the power of 0.5, 100 to the power of 0.5. This will cancel out, and therefore this fraction is equal to 1. And the marginal productivity of labor is also equal to 0.5. Hence, we are working with the following production function. Let's have a look at this graphical representation of the output function. In case that, for example, we are using 1 unit of labor and 100 units of capital, then it is the case that our output will be equal to 10. So this first dot here is generated in the following way. 1 unit of labor and 100 units of capital leads an output of 10. When we are using 4 units of labor and 100 units of capital, the output will be equal to 20. When we use 25 units of labor and 100 units of capital, the output will be equal to 50. So 25 units of labor, the square root of 25 is equal to 5 times the square root of the number of capital units. Number of capital units is equal to 100, square root is equal to 10, so 5 times 10, this is equal to 50. So what we are using here is a variation in labor input, but we are using the same amount of capital. Capital is equal to 100. Capital does not vary when we created this kind of graph here. The curve, which represents the relationship between output and input holding capital constant, is a concave curve. It is not a linear relationship because of the fact that the marginal productivity of labor decreases in case that labor input increases. What about the marginal productivity of labor equal to 0.5? Can we also see that in the graph? Yes, we can. So in case that we use 100 labor units and 100 capital units, the output is equal to 100. And when labor input increases to 101, then the output increases to 100.4988. So the output increases by about 0.5 units. So the marginal productivity of labor in this point is equal to 0.5. But the marginal productivity of labor is not constant. The marginal productivity of labor decreases in case that the labor input increases. And this is highlighted in the next slide, where we plot the marginal productivity of labor. The marginal productivity of labor is measured in output units, and it is the case that the marginal productivity of labor is downward sloping curve. So in our numerical example, it was the case that the labor input was equal to 100, and hence the marginal productivity of labor was equal to 0.5. So why is it necessary that you know all this stuff? Why is it necessary that you need something, that you know something about the marginal product of labor, production function, and stuff like that? Once more, it is the case that we have to think about slide number 17. We have to think about what is under control of the firm, what kind of decisions have to be made, and it is the case that the company, or to be more precise, like the manager of the company, like you have to choose like the optimal amount of labor, and you also have to choose the optimal amount of capital in order to maximize profits. The different components of the model are very important in this case study, where we use the components in order to find out what amount of labor should the manager hire. So we will focus here on the management decision, which is related to hiring the right amount of labor. What is the setting? The setting is that after graduation, you take over the responsibility for the very famous Hasmark grill and mini golf. On your first day of work, you are checking whether the business is operating at its profit maximum. So you have to check how much capital is there in this business and how much labor is in this business. You are checking the inventories and you get the following information: that the production factors amounts to K equal to 100 and L is equal to 1. One ice cream, like one Hasmark waffle, can be sold at the price of 30 Danish krona, and labor unions have fixed the nominal wage at the wage rate of 90 Danish krona. From your studies, you can still remember that the production function in each and every business is given by production function is equal to K to the power of 0.5 times L to the power of 0.5. The assumptions are as follows. For the moment, capital is fixed and cannot be adjusted in the short run. Only labor is variable, and the big question is, what should you do in this setting? Is the amount of labor equal to 1? Is that appropriate? Should you hire more labor? Or should you put the existing worker like on a reduced contract and let him work like only 50% of the hours? Let's check. Like in a first step, of course, it's very important to calculate the marginal productivity of labor. Let's do so. Like a derivative of the production function with respect to L gives you this relationship here. And now we have to plug in the numbers. We have 100 capital units and 1 labor units. When we take the square root here and there, we get 0.5 times 10 over 1. So the marginal productivity of labor is equal to 5. And this has to be interpreted in the following way. Like one additional worker could create like 5 additional ice creams per hour. The ice cream could be sold at the price of 30. Therefore, the marginal revenues of one additional worker is equal to P times marginal productivity of labor, so 30 times 5, and this is equal to 150 Danish krona. The marginal cost of one additional worker is only 90 Danish krona. So when you hire one additional worker in this situation, the profit would increase by 60 Danish krona. Revenues would increase by 150, and the additional worker cost only 90 Danish krona, so that this is profitable. The conclusion has to be hire more workers. So as long as the product of the goods price times the marginal productivity of labor is larger than the wage rate, then you have to hire more workers. The labor demand of Hasmark Grill will not affect Denmark's wage rate. Denmark's wage rate is constant, it's given, it's equal to 90 Danish krona. Also, the additional output does not affect the price of an ice cream. Price of an ice cream is set to 30 Danish krona. But the additional labor input would affect the marginal productivity of labor. The marginal productivity of labor would decrease until we get to the equilibrium where the product of price times marginal productivity of labor is equal to the wage rate. So this equation here in 23 is a profit maximization condition. So this has to be fulfilled in order that we receive a profit maximum. What about the manager of the ice cream shop in Hasmark? Is he doing these kind of calculations? To some extent, yes. To some extent, no. To some extent, no. Of course, I believe that the owner of Hasmark Grill has never attended an economics course at the university, so he does not know the term marginal productivity of labor. And the owner also does not know how to derive the marginal productivity of labor in case that the production function is given. So of course, the manager of Hasmark Grill is not doing these kind of calculations. But of course, the manager of Hasmark Grill has a very good idea due to the fact that he's a very experienced manager how the marginal productivity of labor looks like in the real world. So he knows at which point of the production function the place is getting crowded and one additional labor unit does not make sense. So the manager of Hasmark Grill really has an intuition about how marginal productivity of labor looks like, and he's definitely doing this comparison. So he's thinking about what is the output of one additional labor unit. The manager knows it from his experience how this component looks like, and he definitely knows how this and that component looks like. And I'm 100% sure that even the manager of Hasmark Grill is performing this kind of calculations. So where do we stand now in our graph? Let's have a look. This is once more the same graph as before, marginal productivity of labor on the vertical axis and labor input on the horizontal axis. The only difference is that now we are zooming in, so the horizontal axis only runs from 0 to 6.5 and not to 130. So we are really zooming in here, and in the beginning it was the case that we were working with one labor input. Marginal productivity of labor was equal to 5, and it makes sense to hire one additional worker because 5 times 30 marginal revenues is equal to 150. Marginal cost is only equal to the wage rate of 90, so we can increase profit when we hire one additional worker. What if we have hired 2 workers already? Then the marginal productivity of labor decreases to the value of 3.5. Does it make sense to hire more labor in this situation? Let's do our calculations. 3.5 times 30, this will be equal to 105. 105 marginal revenues are still larger than the marginal cost of one additional worker, and hence we should also hire more labor in this situation. So we should hire more than 2 labor units. What is the optimal amount of labor? We can derive it in the following way, that in the first step we are putting the P on the other hand side of the equation so that we have a relationship between the marginal productivity of labor and the real wage. When we plug in the numbers, then it is the case that the real wage takes the value of 90 divided by 30. The real wage is equal to 3. What does this number 3 imply? The number 3 implies that in case that one person is working for 1 hour in Hasmark Grill, he receives a wage rate equal to 90 Danish krona, and when this person would buy goods for these 90 kronas, the person could buy 3 amounts of ice cream. So the real wage the person is working for is 3 units of ice cream. We already learned that this condition has to be fulfilled, this is a profit maximization condition, and therefore the manager knows that the marginal productivity of labor has to be equal to 3. We can go back to our graph. We have to find the marginal productivity of labor equal to 3, which is given by the real wage. And then we know from this graph that the optimal amount of labor is about 2.75. So we should hire 2 units of labor and then 1 person which only takes 0.75% of a shift. So 2.75% of the labor units is the optimal amount of labor. I think that we learned a lot in this chapter 3. We had another look at the circular flow of the economy, and we came up with some assumption with respect to the factors of production. The factors of production, capital and labor, are constant in the economy. Of course, capital and labor is not constant in the single firm we are looking at. Like the manager of the firm has to optimize labor input and capital input. We also learned about the production function, and this production function has special characteristics like constant returns to scale. We demonstrated that by looking at the country example Denmark versus Sweden. Afterwards, we zoomed in. We zoomed into the firm, and we learned that the prices are constant from the perspective of a firm. The goods price is given and the 2-factor prices are also given, and the manager of the firm has to make a decision with respect to the right amount of labor and the right amount of capital. In order to make these kind of decisions, we have to think about the marginal productivity of labor, so we introduced this term MPL, marginal productivity of labor. Afterwards, we had a look at the following case, Hasmark Grill, where the manager has to find the optimal amount of labor input, and the goods price was given, factor price was given, and we learned about the profit maximization condition. The profit maximization condition is that price times marginal productivity of labor has to be equal to the factor price of labor has to be equal to the wage rate. And then we are able to use this graph in order to find out what is the right amount of labor input for the company we are looking in. I would like to give you some time to digest. So please have a look at the textbook, read a little bit more, and have a look at the slides. Thank you very much. Have a nice day. Bye-bye.